Hello, my name is Brad Morse and I work at the University of Colorado at the Centers for American Indian and Alaska Native Health. Today we're going to go over session number 4, Sink and Float. This session will take about 35 minutes for the youth to go through. There's several equity issues that we're going to be exploring during the session. The first equity issue is small groups and being able to share your thoughts and your predictions in a small group and having respect for one another's perspectives and allowing each other to share ideas and thoughts about what's going to happen. The second equity issue that we'll be going over in this session is the idea that sometimes there's not only one correct answer, or that it's not always important to get the correct answer. That when you're going through an experiment like Sink and Float, the real positive thing that we're going to be doing is thinking out loud, talking with our peers, and sharing our ideas. So the idea of going about an experiment and just trying to learn. That the correct answer isn't the important thing, but the process, the journey to finding an answer and going through the learning process. So several student activities that we'll be doing today. The student activities will be prediction, exploring density, the scientific process, working in small groups, and recording data. All of these elements are something that a scientist does on a regular basis. And we want to show the youth that they are doing science by doing, the process of making a prediction and collecting data. All those type of things are scientifically practiced by scientists, so we'll be doing that today and thereby doing our own practice. There's a lot of skills that the youth are going to practice today as well, and they'll be learning, such as classifying, deciding what object has the most density or what has more density, collecting and recording data on our log sheets, comparing the results of our experiments from one object to the next, making a hypothesis about what's going to happen when we put objects into the water, and making predictions and sharing those with our peers. So again, this session takes about 35 minutes. You'll want to lay out all your materials in the classroom before the youth come. I think when the youth come and they see the objects on the table, they'll get excited about wondering what we're going to do today in after-school science. Let's go over the terms that will be used in session number 4, Sink and Float, in the after-school science program. The first word we have is density. An object's mass divided by its volume. Volume is the amount of space an object takes up. Mass is the amount of matter which it contains. Two items of the same dimensions take up the same amount of space, but may have different density. The item that is more dense will weigh more, e.g. a block of lead is more dense than a block of wood of the same dimensions. Float, to remain suspended within, on, or near the surface of a liquid. A cork, which is less dense than water, will float on the surface of a pan or body of water. Sink, the move downward or toward the bottom. A penny which is denser than water sinks to the bottom of a pan of water. Surface tension, the molecular forces which cause the surface of liquid to behave like an elastic skin continuously being pulled. Viscosity, a liquid or semi-liquid's resistance to flow. Viscosity describes how thick or thin a liquid feels. Oil feels thick and flows slowly. Water feels thin and flows quickly. Volume, the amount of space an object takes up. Quarts, pints, cups, are all measures of volume. A quart of milk or a liter of soda bottle describes how much space the milk takes up. Weight, the amount of pull on a person or an object by Earth's gravity. A weight of 120 pounds is actually a measurement of gravitational pull up to the moon, where gravity is 1/6 of the Earth. A 120-pound person would weigh only 20 pounds. This last term, weight, is a good idea to expand the knowledge that we're talking about in session 4, Sink and Float. You can talk about the Earth's gravitational pull and how it varies on the moon. So these are the words that we'll be using in session number 4 for after-school science. After the students have come into the classroom and gotten familiar with the objects on the table that you've arranged, and the excitement is building, you'll want to go right into the session and talk to them about what we're going to be doing today. The first thing to do is to ask some open-ended questions. We have some open-ended questions that are suggested in our manual for after-school science. Let me read them aloud here. The first one is, any ideas about what happens when you put objects in water? The second open-ended question is, can everything stay on top of water? Why or why not? The third is there a name for what happens when something stays on top of the water? And our fourth question that is suggested in the manual is there a name for what happens when something drops to the bottom of a pan of water? So you'll want to think about these open-ended questions and maybe come up with some of your own open-ended questions. For example, you may ask youth what the practical use of sinking and floating might be. For example, transportation. A boat floats and we travel across large bodies of water in boats or small bodies of water. And so that's a practical thing that we do with the concept of floating. After you've engaged the youth into the conversation about sinking and floating, you'll want to move into the second part of the session and give them a data sheet, which you have in your manual. You'll want to print out enough data sheets that you have as many groups so that each group has their own data sheet. They'll also need a pencil or a pen to make their observations and predictions. You'll want to go through the idea of collecting and recording data with the youth. This might be the first time they've done it. So the data sheet is pretty straightforward and it has columns and rows, and you'll want to talk to the youth about how they're going to go through this session and record their predictions on the data sheet that we have here. The first column is item name, where they'll record the name of an item, for example, a cork. Then they're going to place a check mark in either column for sink or float, whichever they think is going to happen. And then we'll want to record why they think that's going to happen. That's really the main point of this session, is thinking about what's going to happen with understanding vocabulary words and concepts like density, volume, sinking, and floating. And then we have a results column on the far right-hand side, where after they drop the item into the water, they're going to make a check mark in this column to record what actually happened. Then they can compare their results to their prediction, and they've really gone through the scientific process by doing this data sheet. So this is a really important piece for the sink and float session. At the bottom, you'll also notice that we have some space for the youth to write down what they learned through the process of doing this particular project. So after you've given them the data sheet, you'll ask them to each pick an item and make a prediction on what it'll do. For example, you could give the cork to someone, or someone may naturally choose a cork, and they'll see that it floats in the water, whereas the nickel won't float. It goes right to the bottom. So that's a fun start to the activity, but then you can get creative and do some more things with the objects that you have. You know, you have one of these sponges, and you'll ask the youth if it's going to sink or float, and go ahead and put it on the water. And we see that as the sponge collects water, it starts to sink, but it never goes to the bottom. It stays on top of the water. This is a really good learning opportunity for your older students now, where you can kind of go further in the learning about volume. In your manual, on page, page 46, you can expand the learning for the older students, and this is what our manual says. It says, help older students understand that an item placed in water displaces or pushes away a certain volume of water. If the volume of water that's displaced weighs more than the object will float. So in the example of the sponge, it obviously weighs less than the water that it removed or moved, pushed away from the sponge, therefore it floats. Whereas the nickel, on the other hand, when you compare the volume of water that this nickel pushes away, the nickel weighs more than that volume of water, so it sinks. These are really difficult concepts and words for youth to learn, but that's why we're doing it in a safe environment at the clubs. We can talk, and the peers will talk to one another, and they'll start to understand that these scientific words have practical and everyday meaning for them and their families while they're at school or even in sports. So that's a lot of fun, and we have to expand the learning as we go through the process. Another fun thing to do is to take an object that obviously floats and to try to make it sink. So you have tape and string in your toolkit, and you can attach weight to a cork, for example, to see how much weight you have to add to the cork to make it sink, whereas it naturally floats. So that's another expansion of the learning that we can do on top of the vocabulary words. I think in this particular session, it's really important to go over the vocabulary words first, and then start into the exercise with the different objects. You'll want to use the words that you have in the vocabulary list while describing what's happening with the youth. So, if they understand the words, they'll have an easier time understanding the concept when they watch it happen in front of them and making predictions. So it's a good idea in this particular session to go over the vocabulary words first. These objects all have different properties and they're going to do different things, and that's what's fun about this session, is making predictions and then recording it on your data sheet and then comparing your prediction with the results after watching it. For example, a bottle with a cap off floats on top of the water. But a bottle with water in the bottle and a cap floats. This might be a tricky one for youth. They might think that because there's some liquid in it, it might float. Or the amount of liquid in it might influence whether it sinks or floats. So if you fill the bottle entirely, as much as you can, with water, and then put the cap on, it may act differently when you do the experiment. It seems to still float, even with more water in it. So you can start adding heavy objects in the bottle to see what happens after adding weight inside the bottle with the water. So if you had a bunch of change, for example, or a bunch of rocks outside of the club, you can put them in and load up the bottle and see what happens with extra weight. These are really interesting and fun, creative ways to expand what we're doing in this session. You have a lot of tools in your toolkit to play with, and I think the youth will really enjoy making predictions and comparing the results with their predictions. Please enjoy the session and help the youth understand these really important concepts so that they can understand the scientific process, how one goes about making predictions, and how one records their data as they go through the scientific discovery process. Thank you for tuning in for session number 4 of the After School Science program. Have a nice day.